Hey Math One, how are you doing? Mrs. Machado here. I'm trying something new. I'm not using my document camera. I'm using my Chromebook so that maybe I can point to stuff and explain things a little bit better. So I'm going to look at slope, just a quick review. Remember, you've already looked at this, so hopefully it's something that you've looked at before and you already know, so we're just reviewing so that we're fresh when we start those worksheets. So, slope. Ooh, this is fun. Okay. So remember that slope is change in y over change in x, which is also rise over run. Okay, so if you've got 2 points, let's say I've got the points 1, 4, and then -2, 6. Right? If I want to find my slope between those 2 points, what I've got to do is I've got to figure out what my change in y and my change in x are. So in order to do that, I'm going to subtract my y's and then subtract my x's. So I'm going to have 4 minus 6 all over, I'm going to have a 1 minus a -2. Remember, those double negatives will change what you're doing, right? This ends up being addition here, so on top I've got a -2, and then on the bottom I've got a 3. So slope from 2 points should be something that you're pretty familiar with, I hope. The next thing that I want to look at is that slope-intercept form. So let me get this on here real quick. Slope-intercept form is a form of a line that you should be pretty familiar with. Hopefully you've used it quite a bit, but it's y equals mx plus b. If we were in class right now, I would have asked for it and you guys all would have shouted out because you know how to use this. So when I'm looking at this one right here is my slope. And then this one right here is my y-intercept. Okay? So when we're looking at this, I can get everything that I need to graph a line directly from my equation. So if I've got an equation like y equals a 2x plus 7, right? Y equals 2x plus 7, then this piece right here, this is my slope. So m is equal to 2, and if we remember, my slope is rise over run, right? And this, it's not always going to be given to you in fraction form, but remember with slopes, we like fractions. So we're actually going to turn it into 1. So my slope becomes my directions. I'm going to go up 2 and then over 1. Right, my rise and then my run. This piece right here is my starting point. Okay, my starting point tells me where to start on my y-axis. Okay, so I'm going to go ahead and switch over to this here. Isn't this cool? This is so cool. All right, so y equals a 2x plus 7. That is what I'm going to be graphing right now. So I've got to start with my y-intercept, which is my 7. I'm going to go up 5, 6, 7, which is right here. Sorry. There you go. And then with my slope being 2, it's 2 over 1, right? So up 2 over 1, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, right? And that's how I can graph my line. Remember, I can also reverse it, and I can go down 2 and then back, down 2 and then back, down 2 and then back. And in order to graph my line, I don't have a ruler handy. That would have been a good idea for this, but oh well. In order to graph my line, I just extend my points. How does that look? Not a very good line, but hopefully it's good enough for what you need. Let's look real quick at what if it's not given to you in that form and they want you to graph it. So let me give you another example. Let's look at 3x plus 2y equals 10. Okay, this is the standard form. So standard form is when I've got my x's and y's all on the left-hand side, my constants over here, and then my numbers in front of my x and y, the coefficients, are whole numbers. So looking at this, I need to get y by itself because I need it to be in this form. Y equals mx plus b. I need it in that form there. So the first thing that I'm going to do is I'm going to subtract 3x from both sides. Maybe I should get a helper to hold my stuff while I do this. That would be nice. So 2y equals negative 3x plus 10. And then I need to divide everything by 2. Divide by 2. Because I need to get that y all by itself, right? So here I'm going to have y. And then this is going to be a negative 3/2 x. Remember, with slope, we do not want to go to decimals. 1.5 for slope is actually problematic. We want to go down 3 over 2. Remember, fractions are a good thing when we're dealing with slope. And then it's going to be plus 5. Now that it's in this form, I know that my slope is negative 3/2 and that my y-intercept is 5. So let me go to a graph. I'll write it up here again. Negative 3/2 x plus 5. So negative 3/2 x plus 5. I'm going to start off by counting up 5. And then remember, these are my directions. This is going to make me go down 3 and then back 2. Or sorry, no, down 3 and then this way 2. When we're graphing and we're looking at our slope, it's really easy to make a mistake and have it go the wrong direction. So if I know that my slope is negative 3/2, I know that it should be going down as I go from left to right. So when I first started off, I said, oh, I'm going to go down 3, and then I went back 2. And I realized that wasn't correct because this one is going to have a positive slope. And I realized, oh no, I have to have it go this way. That's one way that you can just double check and make sure that you're going in the right direction. Each time I go down 3 and then over 2. Down 3, over 2. I can also go this way, bonk, bonk, and then, hold on, it's hard to draw the line when I'm holding it upright like that as well. And then I can connect my dots to graph my line. Okay? One other thing that I want to look at real quick are vertical and horizontal lines, because those are the ones that cause some problems for people. So if I have a vertical line, these are the ones that cause problems all the way through calculus because they're hard to remember. So a vertical line would be something like this. Right? For this vertical line, on this line, every single point has the same x coordinate. So I'm going to put some points on here. This here is 5, 4. 6, 7, 8, 9. 5, 6, 7, 8, 9. This is 10, 4. Oh, sorry. I mean 4, 10. Would help if I put them in the right spot. This point right here is 4, negative 3. Okay. Oh, no, hold on. I can't even count. Hold on. Those should all be 5s. This is over 5 up 4. This is over 5 up 10. This is over 5 down 3. Okay. You'll notice all of those x coordinates are the same. So anytime that you've got a vertical line, it has the form x is equal to some number. So x is equal to, in this case, x equals 5. Okay? If I'm looking at a horizontal line, let me put one on here real quick. This is a horizontal line, right? So let me write horizontal up here. So with a horizontal line, every point on here has the same y coordinate. So if I've got this point right here, this is y equal, hold on, negative 5 and up. This one goes back 5 and up 2. This one goes over 4 and then up 2. And so on. You'll notice that y coordinate never changes. So these ones have that form y is equal to a number. Now these ones seem a little bit backwards because if you think y equals a number, you're probably thinking that, oh, well, y is 7, so it's going to look like my y-axis. But that's a little bit backwards. Instead, y is a number, so everything has that same y coordinate. You go to whatever that y number is, and then you go over. Okay? Likewise, if I said that x is equal to negative 2, I go back here to x is negative 2, and then I would go up and down Those are those vertical lines. Okay? Hopefully that's enough to get you going with the graphing and slope, all that kind of fun stuff. So remember, if you have any questions, call me, email me, send me a message in Classroom. Whatever it is that you need to do, we'll set up some sort of a Zoom meeting or whatever we can do to get this figured out. So good luck and let me know how you're doing.